Hello and welcome to our lesson on finding all solutions to trigonometric equations. We're only going to work with cosine in this lesson, but we're going to have horizontal and vertical transformations, and we will use trig exact values. Later we'll use values that require a calculator. So for instance, this should look fairly familiar. I'm going to expand your view of what the unit circle would look like. We're going to extend the unit circle. So draw and label two triangles where the cosine of theta equals 1/2. And we would see that cosine's positive to the right, and with a 1/2 for the adjacent side, we know that this reference angle is 60 degrees, and that this angle over here in standard position would be 300 degrees. If we were to look at the unit circle on an extended graph, basically theta along the x-axis, y vertical, we'd see y equals 1/2, see where it intersects the curve of cosine, and in looking at this, we'd see this spot here is 60 degrees, and this spot here would be 300 degrees. Okay? We want to start seeing the sinusoid that we've seen in Algebra 2 and then earlier in the semester as well. Now, how do these angles relate to the inverse cosine? It is the angles on the unit circle. In this case, we're restricting our values from 0 to 360, that's our domain, where the cosine equals 1/2. And we saw it in the unit circle, we see it in the sinusoid with a domain from 0 to 360. Go ahead and try this one. Hit pause. Okay. We know that cosine is negative on the left side of the y-axis. We can draw some reference triangles over here. We also know that since negative square root of 3/2 is the adjacent, that's the long side. Short side is going to be 1/2, so that's a 30-degree reference angle. 30 degrees before 180 is 150 degrees, and 30 degrees past 180 is 210. So our solutions on the unit circle are theta equals 150 and theta equals 210. And if we were to take some time to look at the graph of y equals negative root 3/2, just a horizontal line, and the cosine graph, we'd see that where these two intersect are going to occur at 150 and 30 degrees past 180. This is our 180 right here, 210 degrees. And what we want to notice here is that these angles are related to the inverse cos because they are the angles on the unit circle from 0 to 360, where cosine equals negative root 3/2. Now we're going to change its domain. We're going to start to expand that a bit, so you're going to want to get familiar with that. And our notation is going to show, and this isn't really critical for this lesson, but just so you recall, parentheses are open, square brackets are closed or included. And now we look at an interval that's different than the unit circle. In fact, from negative 540 all the way up to 540, we're changing things a bit here. And we're also changing the period in this case. Some transformations are going to start to occur. So we'd ask, where is cosine equal to 1/2? And we know that it's 1/2. When cosine's 1/2, it's the larger of the 30, 60 reference angles. So we'd have 2/3 of theta. If we did the inverse cos, 2/3 of theta would equal 60 degrees or 300. And thinking about spinning around the unit circle, we can spin forward or backward 360 degrees and end up in the exact same place. And we'll look at a graph that shows that for the sinusoid. To get theta by itself, we multiply by the reciprocal, 3/2. When we do that, we get the 2/3 to cancel out. So we'll just get theta. And then if we were to take 60 divided by 2, that's 30. 30 times 3, this would turn into a 90. Half of 300 is 150, times 3 is 450, and then 3/2 times 360 is 540. What we'd end up with is theta is 90 plus 540n, and theta equals 450 plus 540n. And this n is thrown in to show that we can go forward or backward from our solution one complete period. So n is an integer, meaning positive or negative whole numbers. So if we 540 forward or 540 back, a complete period, we'll get continually the same values. These are some of the results of periodic functions. So to look at that, if we saw on the sinusoid, the graph of y equals root 2 over 2, the graph of y equals cos 2/3 theta, we set y's equal, we see intersections at these places. In this case, 90 degrees and 450 degrees. Also back here at negative 90 degrees and negative 450 degrees. Okay, and we start to notice a little bit of symmetry here, and we've seen it before with cosine, something to pay attention to. Now, how do these angles relate to inverse cos? The solutions on the unit circle have been expanded all the way out to negative 540 to 540. Okay, you try this one now. Notice the domain's different. We have quite a few transformations occurring. So work this problem, hit pause, go back and check your answers, and make sure that this process is seeming clear to you. We've got a few more examples to go through, but this was where things start to get a little bit tricky. Okay, if we look at this problem, we need theta. We've got quite a few two things happening. We have to add square root of 2 on both sides, and we have to divide by 2 on both sides. We get done doing that, we get that the cosine of 3 theta equals square root of 2 over 2. Now we think, where is cosine equal to square root of 2 over 2? If you know your unit circle, it's going to be at 45 and at 315, where cosine is positive. Unfortunately, we're trying to find what theta is. We now know what 3 theta is, so still have a little more work to do undoing something on the inside of our function. We have to divide by 3 across everything. And when we do that, we find theta then equals 15 degrees plus a new period, 120, and 105 plus 120. And if we were to graph the equations, y equals 0, and the equation root 2, negative root 2 plus 2 cos 3 theta, we'd see a shortened period, and things shifted down a bit as well. And if we look at these values, try to make a correlation here, the value here is going to be 15 degrees, and the value here is 105. And likewise, again, because of symmetry, but also just the answers we have, negative 15 degrees and negative 105. All right? And that's what we get here. It's worth plugging these values into your calculator just to verify that they're accurate. And so when we look at a general solution, a way to look at all values for cosine, because of its symmetry, we can find that depending on what A is, and in the previous example there was a stretch or shrink, but we're going to be able to write plus or minus because of the symmetry, whatever our first solution is, and then adding a period in that case. And if we have radians, we'd use 2 pi instead of 360. And now when we look at our previous problem with this sense of symmetry, we noticed previously that at 15 degrees and negative 15 degrees, 105 and negative 105, we had values where this expression equaled 0. And so we wrote 15 and the 105, thinking going just counterclockwise on the unit circle. We got our 120 for our period. If we were to take a moment and notice how we got the values, we could take 120 away from 105 and get negative 15 degrees. Likewise, we could subtract 120 from 15 and get negative 105 degrees. So our 15 and negative 15, our 105 and negative 105 come out of our equation written in this form, but also we see it in symmetry. And so we look for a shortcut. We have this shorthand way mathematicians write their solutions. Theta equals positive and negative 15 degrees plus 120n, where n is a positive or negative whole number. And so now these angles relate to the inverse cos in the sense that our solution is expanded to all possible solutions, all the way from negative infinity up to positive infinity to depending on how many periods we add or subtract. And now we'll go ahead and solve this equation algebraically, just relying on our knowledge of the symmetry of cosine and our trig exact values. We're going to subtract 5 from both sides, giving us 2 cosine 3 theta minus 10. And then divide by 2 on both sides. We get cosine 3 theta minus 10 equals negative a half. Trig exact value we should know. Later we will have to use a calculator. We're going to undo cosine with arccos or inverse cos. Our book tends to use the expression arccos. Other applications, inverse cos and arccos, are thought of as the same. But when we inverse cos the cosine, that cancels out, leaving 3 theta minus 10. That should look good for solving for theta. A couple operations left. This gets a little tricky. Our definition from before, plus or minus the inverse cos of negative a half plus however many periods times an integer, positive or negative whole number. So in this case, what is the inverse cos of negative a half? And we want to consider where cosine is negative. That's on the left side of the y-axis. So the reference angle of 60 degrees on the left side gives us a plus or minus 120 degrees plus our period of 360n. We divide by 3 on both sides. And I'm going to separate the plus and minus here because when we undo the minus 10, it's going to have an effect that we got to be careful about. So if this cancels out, I get theta minus 10 equals a positive 120 over 3, which is 40 degrees, plus the period 360 over 3, 120, n, and we get another value, negative 40 degrees, negative 120 over 3, plus 120 degrees n. When I add 10, I'm going to add 10 to the displacement, not to the period. The period doesn't expand by 10 degrees more. I just shift the curve to the right 10. So I get theta equals 40 plus 10 is 50 degrees plus the 120n. And then negative 40 plus 10 is negative 30 degrees plus 120n. And that is our answer. Phase shifts do cause us to lose a little bit of the elegance of our answer because we can't just put a plus or minus in front. So remember that first value, 120 over 3, don't just add 10 or undo this side and put a plus or minus in front. You need to separate plus and minus when you're dealing with a phase shift. Okay, you give this one a try. Hit pause. All right, first thing to do is undo the outside stuff. That's pretty straightforward. And we get a negative 2. We divide by 2. We get cosine of 2 theta minus 10 equals negative 1. In this case, we're going to arccos or inverse cos. The book tends to use arccos, so that's what I'm going to use. When we arccos both sides, we're undoing cosine. That cancels out, and that leaves me with 2 parentheses theta minus 10. Where does cosine equal negative 1? Well, cosine starts at its max and goes down halfway through. It's at negative 1. So I know that that's at 180 degrees. So plus or minus 180 degrees. If we went back, negative 180, it would be negative 1 as well. Plus our period, 360n. And we do want to put degrees in there. Okay, dividing by 2. In this case, we don't need to worry about division, but when we add or subtract, we have to consider the positive and negative. We get theta minus 10 equals 90 degrees plus 180, and we get negative 90 degrees plus 180 degrees n. Adding 10 gives us theta equals 100 plus 180n, and theta equals negative 80 plus 180 n. If you're struggling, it's okay. We're going to spend time in class, and we're also going to have to expand this to values that are not trig exact values, as well as radians. So if you're confused, this will be a vital video to refer to if you get confused on how to find the general solution for cosine. Here's your on your own. We'll see you in class.